Hey friends, it is time for us to continue in Chapter 5, and we are talking about perpendicular and angle bisectors today, but I want to do a quick review of what we learned on Lesson 5.1. Remember, on Lesson 5.1 we have our triangle, and with that triangle, if we find the midpoint of two sides of that triangle, and we connect those two midpoints, we call that the mid-segment. And then we discovered properties using our rulers and stuff the other day. And the fact that we know the mid-segment is always parallel to the third side of the triangle. And let's say if we know the third side is 12, we know that the mid-segment is half its length. So we could use that to find the missing parts of a triangle. We even did it for working with perimeter and things. So it was kind of critical that we understood where those come from. Now today, we're going to go and use some other things that we worked with. We're going to talk about perpendicular bisectors and angle bisectors. So let's remember quickly what a perpendicular bisector is. A perpendicular bisector divides a line segment perfectly in half, and it forms right angles. So that was our perpendicular bisector. And we're going to be using this a lot more in the chapter. But we also had an angle bisector. And when we have angle bisectors, it's a ray or line in the interior of the angle that gives us what? Now, let me remind you how we learned this in class. If I give you an angle bisector, then you give me what? Two congruent angles. So that was our angle bisector. So don't forget that we're going to be using those today. So that's just a quick review of some terminology that we have. Well, we have another term today, and it's really simple for you to do. It says when a point is the same distance from two or more objects, that point is said to be equidistant. Kind of like our equilateral, all the sides are the same length. Equiangular, all the angles are the same. That's kind of the idea that we're using behind this. So today we're going to apply two theorems for our perpendicular bisectors, and then we're going to do two theorems for angle bisectors. So here's our first one, the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then the point is equidistant, so equal distance, make sure I can write an N there, from the endpoints of the segment. Basically it's saying, hey, I know X is on this perpendicular bisector. It could be anywhere on there, so just remember anywhere on that perpendicular bisector. Then I know that the two sides right here are going to be the same length. Now, how did we prove that? Well, we proved that using side, angle, side congruent. So it's an easy way for us to figure it out. Now, we have the converse of the perpendicular bisector theorem. It's doing what? It's when you switch your hypothesis and your conclusion around. So this one says, if a point is equidistant from the endpoints of a segment. Okay, so if a point is equidistant, so these two segments are equal, then it is on the perpendicular bisector of the segment. Again, how is this proven? All using congruency. Because once we know that point is on there, we can use our right triangles. Now look at these. What type of triangles is the big triangle going to be? An isosceles triangle. Remember our theorem from last week that said if I have an isosceles triangle and I go ahead and bisect the vertex angle, I'm also make the perpendicular bisector. Aren't those very similar diagrams? Yeah, so that's the kind of cool relationship that we have with these. Well, let's finish up the examples here on the bottom. It says use the diagram for items 1 through 2. Now, looking at this quickly, let's look at the first one. It says, given that segment FH is the perpendicular bisector of EG. if they tell you something's a perpendicular bisector, midpoint, angle bisector, you should always mark up your diagram that way. That's why many of your textbooks are just covered here, because that helps people see it. It says if it's the perpendicular bisector, you should have your right angle being formed and your two congruent segments. Now I'm going to label the information on there. We know EF is 4y minus 3. We know that FG is 6y minus 37. Now, is point F on the perpendicular bisector? Well, then you should be able to automatically assume that those two segments are congruent. So let's do number 1 up here so it gives us a little bit more room. So I can set them equal to each other. I know by our first theorem, if a point is on the perpendicular bisector, it's same distance from the endpoints of it. I make that giant isosceles triangle. So I go now 4y minus 3 is equal to 6y minus 37. Subtract 4y from both sides. I get negative 3 equals 2y minus 37. Add 37 to both sides. We get this to be 34. Divide both sides by 2. Y is equal to 17. But that's not what I'm looking for. I'm looking for the length of segment FG. Remember, no bar means length. So remember, plug it in, plug it in. So we're going to plug and chug. So I'm going to go length of segment FG equals 6 times 17 minus 37. Well, that's 102 minus 37, which equals, I do believe, 65. Now it's not degrees because we're looking for the line segment. So remember, just because it's a triangle, we're not automatically looking with the angles. So that was number 1. Now using the same diagram, I'm going to redraw it here so we can see it a little bit better. Here's E, here's G. I'm going to go straight down. And we should have F right here. Now they tell you the following. The length of segment EF is 10.6. The length of segment FG is 10.6. That means these two segments are equal. That means F is the same distance away from E and G. Therefore, that means segment, oops, I forgot my H here. That means segment FH has to be the perpendicular bisector. Now I'm going to go ahead and finish filling the information. They tell me EH is 4.3. Well, how do I find the length of segment EG? Well, those had to be the same because it's on the perpendicular bisector. To get EG, you just got to go 2 times 4.3, because I know that one's 4.3, which is 8.6. So we can use those. All right, we're going to go to the other page and work some more examples together.